Hey guys, we're gonna learn about bubble sort today. And what is bubble sort? Well, bubble sort is a computer science concept, more of algorithm concept. It's one of the simplest sorting algorithms to sort a collection of data. So in this case, we're sorting from the lowest to the highest. You can change the sorting condition based on what you need, like highest to lowest, but the concept is the same on how these numbers are sorted. One thing you should know is that bubble sort is easy to do, but it is inefficient and very expensive on the memory. So how does it work? Imagine yourself having a collection of ping pong balls. It has numbers put on these orange ping pong balls. You're going to look through all of these numbers. So on the first pass, you're going to compare the first two set of ping pong balls. In this case, it's 5 and 2. So we're sorting from lowest to highest, and is 5 bigger than 2? Well, yes, it is. So it's going to be pushed to the end of the row, and 2 is going to come before. On the second comparison, you have 5 and 3. So the next set of numbers. And 3 is lower than 5. So it's going to be swapped to the back. So 3, 5. And finally, we're going to compare the last set of numbers. So 5 and 1. And 1 is lower, so it's going to be swapped to the front. So we finished our first pass. But as you can tell, this is not sorted yet. So we will have to do this exact process again on the second pass. So we're going to look through all of the numbers again, through all the sets. And here you have 2 and 3. 2 and 3 is already sorted, so nothing needs to be done. Going to the next set of numbers, you have 3 and 1. 1 goes in front because it's lower, 1 and 3. And on the last set of numbers, you have 3 and 5. These are already sorted. Nothing needs to be done, but as you can tell, it's not completely sorted yet, so we're going to go again onto the third pass. So the third pass, 2 and 1 needs to be sorted because 1 is lower than 2. So we're going to swap them. On the second set of numbers, 2 and 3, nothing needs to be done. So go to the last one, 3 and 5. Nothing needs to be done because that's sorted. Now, the entire set is sorted, but the computer doesn't know that. So it needs to confirm everything is sorted by going through a final pass where it compares all of the sets of numbers and makes sure that they're already sorted before the loop can end. So a summary of how that works is that there are two loops. The outer loop continues running the inner loop until it is told not to. And the condition to stop running that is when it detects that nothing has been swapped through the entire check of all the numbers. So in our last pass here, this is what it's doing. It's going through all of the sets of numbers and telling, oh, nothing has been swapped on the first two sets, nothing has been swapped on the second set, and nothing has been swapped in the last set. So now you can stop. The inner loop, which is also what I just showed you, is what does the comparison. So it actually jumps between the pair of numbers. The inner loop is comparing the first set, and then is comparing the second and third numbers, and is comparing the last two numbers. So in this case, you can kind of see how it is bubbling to the top visually. Like I said, the nested loops makes this algorithm very expensive to run. So let's look at a JavaScript example. In here, we're going to focus into the red outline. And as you can tell, the outer loop is actually the do while loop. And what it's basically saying is that if it detects something has been swapped, keep running the inner loop of comparing all the sets of numbers inside until it detects that nothing has been swapped. Then you can break out of this loop and continue running the rest of the code. And this is what the final pass did. While it's inside the inner loop, what it's going to do is that it's going to run through all of the numbers. In this case, it's an array, 2, 3, and 1. And it's going to start from the first number, of course, 0, because indexes start at 0. And as long as it is less than the length of the array, which is 3 at this point, is gonna go through all of the numbers. So let's do a quick example. On the first loop, it's gonna go through I is 0. So in this case, 0 index is 2. And it's gonna say, oh, is the array of index 0, which is the value 2, is it bigger than the value of the index 0 plus 1? So the index of 1, which is 3. So is 2 bigger than 3? No, it's not. So it's gonna ignore what's inside here for this loop and jump into the next iteration. And in here, now I is gonna be 1, and because I is still less than the length of the array, it's going to jump into this conditional again, which is I, which is 1 now, is 3 bigger than 1, because it's comparing I plus 1, which is the index of 2. So is 3 bigger than 1? Yes, it is. So it's going to jump into the conditional. And here, what the conditional is basically doing is it's storing a temporary value of the current index, which is 1, the index of 1, but it is storing the value of 3 in the middle position. And then it's gonna assign the current index here the value of the next value, which is found in the next index, which is 1. So it's gonna swap them. It's gonna put 1 into the middle slot. Then afterwards, it's gonna reference the next index, which is 1, and place the temporary value that we stored, which is 3, into this slot. So now it's going to look like 2, 1, 3. And then it's going to say, oh, we detected a swap. So since we detected a swap, later on when this inner loop is done, it's going to tell the outer loop there has been a swap. So do the entire loop again until there is nothing swapped, and when there is nothing swapped, then break out of it. In this case, do while loop has gone through one of the outer loops. It's going to go back into here to do this conditional swapping again, because it's 2, 1, 3 is still not fully sorted. So it's going to try sorting it again until everything is sorted, and then it's going to break out of the loop. I hope this made sense, and if you have any questions, please leave it in the comments below. Until then, see you next time.